Alright, welcome to 3.02. We're going to be rewriting rational expressions. And I want to just briefly say that over the next few lessons we're going to be focusing on being able to represent rational expressions in different ways and to kind of do things with rational expressions so that when we are working in a real-world situation we feel comfortable manipulating rational expressions to help us understand the situation better. Okay, so we're going to build up our toolkit for that so that when we get to those real-world situations we feel really comfortable working with the expressions and equations. I want you to simplify 3/15, show all your work, and then explain, write a sentence or two explaining why you were able to simplify it. Okay, good. So when I simplify, I note that the numerator is 3 and the denominator is 3 times 5. And so I can simplify this because 3 divided by 3 is simply 1 over 1, or 1. And so my numerator is now 1 and my denominator is now 5. And so I can simplify my expression by noting the pieces on the top and the bottom which will divide into each other evenly. And remember that a rational expression is nothing more than a quotient, right? I have a polynomial divided by another polynomial. And so I can look to do the same thing. Alright, so try this one out. Taking the same idea that we use with integers, I want you to simplify this rational expression and include any information that is necessary to be included. So go step by step and make sure you include all the important information. Here again, split your paper in half so that you can show the work that you did on your own, and then when we talk about it you can include any additions. So perhaps you are a little stuck, and that's okay. What I'm going to do is I'm going to give you a small hint to allow you to kind of get started. So notice that when I'm simplifying a fraction with numbers, the first thing that I want to do is I want to break up both the numerator and denominator into its factors. So 15 is 3 times 5, and that allows me to find the common factors. So apply that same idea now to this expression. Pause and try again. Right, hopefully that little tip allowed us to see the similarity and move forward. So what I'm going to do is I'm going to follow the same idea and I'm going to break up my denominator into its factors. So x squared plus 5x, x plus 2 times x plus 3. Okay? So now let's think about, let's keep simplifying here. And what I want you to do is I want you to now go ahead and pause again and continue simplifying all the way through. Alright, now I bet what you did was you said, look, I have x plus 2 in my numerator and I have x plus 2 in my denominator. And something over itself, well, that's going to be 1. So I now have 1 in my numerator, and I can simplify my expression so that it's 1 divided by x plus 3. And that seems much, much more simple, right? I would much prefer to work with 1 over x plus 3 than I would with this expression. Now I want you to think, is this always true? Is it okay for us to cancel x plus 2 over x plus 2 and represent it as 1 over 1? Is it always going to be the case that x plus 2 over x plus 2 is 1? Go ahead and pause the video and think about that. Try some values. Try and find a value where if I plug it in, x plus 2 over x plus 2 won't be 1. Okay, so let's take a look. What I'm curious about is whether or not x plus 2 over x plus 2 is always going to equal 1. And perhaps you thought about what would make this not simplify to 1. And you might notice, what happens if x is negative 2? When x equals negative 2, what do I get? Well, on the top I'll have negative 2 plus 2, and on the bottom in the numerator I'll have negative 2 plus 2. You can do the math. 0 over 0. Well, what's 0 over 0? Is that 1? Absolutely not. Remember, 0 over 0 does not exist. It is undefined. Undefined. And so this should be an excluded value, right? If I were looking at this right here, I would say, hey, x equals negative 2 is an excluded value. Just as, well, actually, I'll let you figure this one out. What's the other excluded value? The other excluded value should be when x is negative 3. So I can't just say x plus 2 over x plus 2 is always 1 over 1. Because what happens when I get to negative 2? Well, when I plug in negative 2, I'm going to end up with 0 over 0. Because it'll be negative 2 plus 2 on the top, which is a numerator of 0. And I'll have negative 2 plus 2, which is 0, times some other number, which is 0. So it's incorrect to say that x plus 2 over x squared plus 5x plus 6 simplifies to exactly this. Because I'm taking out, I'm just assuming that x plus 2 over x plus 2 is always 1 over 1. And that's not true, because what is the value that this cannot, that I must exclude so that I don't end up with an undefined value? The two values that I can't have, so this is the tricky part here. This is the simplification. It simplifies. X plus 2 over x plus 2 is 1 over 1 everywhere except when x is negative 2. So when x is not equal to negative 2, right? This is true only when x is not equal to negative 2 and when x is not equal to negative 3. Because these are the two values that I want to exclude, and hopefully you're seeing now why I call them excluded values, right? They're the values that when I plug into my expression, they make it impossible for me to define. And so when I'm simplifying, I have to be careful, because I can't just cancel x plus 2 over x plus 2. It's not always 1 over 1. There's that one excluded value when x is equal to negative 2. And so, for example, it would be inaccurate for me to say that I can always simplify this to this, because when x is negative 2, when I plug negative 2 in here, I'm going to get 0 over 0. If I plug negative 2 in here, I'm going to get 1 over 1, which is 1. And that's not correct, right? 0 over 0 is not 1 over 1. And so x cannot be negative 2. I must include this as part of my simplification. So I can say, look, it's okay to simplify this function, this expression here, to this expression here, as long as I don't do it when x is equal to negative 2 or when x is equal to negative 3. So it's this function when x is not negative 2 and when x is not negative 3. Some questions for you to work on. Remember, write out the questions and your solutions. If you are stuck, you need to ask some questions, okay? You know how to do these. We have talked about ways to simplify, and you have actually already simplified. Make sure that you include any special notes that you need with your simplification. For number 3, read through carefully. Okay, and my hint is don't tackle this whole piece at once. Focus on finding p of x first. Find p of x first, and then worry about simplifying. And for number 4, use the binomial theorem to expand this binomial. You can go back to the last couple of videos in Unit 2 for a little bit of help with that.